Ignition sequence start.
Good morning, and welcome to this view of the International Space Station Flight Control Room. This team of specialists you see here is keeping an eye on the station's systems and is working with the members of the Expedition 64 crew as they kick off their 6-month mission. That's right, Commander Sergei Ryzhikov and flight engineers Kate Rubens and Sergei Kudzverchkov said goodbye to 3 crewmates this week and kicked off their own mission of scientific investigation, which is scheduled to last into April of next year.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Isidro Reyna. This week marks the beginning of Expedition 64. 2 veteran International Space Station crew members swapped command of the orbiting laboratory during a traditional change of command ceremony on October 20th. The 6-member space station crew gathered together when Expedition 63 Commander Chris Cassidy of NASA ceremonially handed control of the station to Expedition 64 cosmonaut Sergei Ryzhikov of Roscosmos.
We have this small tradition where there's a key to the International Space Station. It's a tool that we use on the Russian hatches to open and close the hatches. And it symbolizes the camaraderie that we have between all of the space agencies. And Sergei, it's with great pleasure and honor that I present you this key and command of the International Space Station. Congratulations.
Ryzhikov officially began his command on October 21st when Cassidy and flight engineers Anatoly Ivanishin and Ivan Wagner undocked from the station. The crew undocked from the Poisk module inside the Soyuz MS-16 cruise ship, re-entered the Earth's atmosphere just over 3 hours later, and parachuted to a landing in Kazakhstan, bringing their 196-day space mission to an end. This week's question comes from Ridgedale Middle School. Students want to know if astronauts ever experience a language barrier while on board the International Space Station. A truly global endeavor, the unique microgravity laboratory has hosted 240 people from 19 countries, almost 3,000 experiments from over 4,200 researchers in more than 100 countries, and a variety of international and commercial spacecraft. Differences of nationality and culture, as well as being isolated for months at a time on the International Space Station, can be demanding. Before astronauts travel into space, they are briefed on the cultural differences they may encounter with crew members from other countries. While English is the primary language spoken aboard the station, crews must also be proficient in the Russian language. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
Chris Cassidy's 3rd trip to the International Space Station started last April on a launch pad in Kazakhstan and wrapped up a 6-month mission filled with milestones for space exploration, plus all his work on science experiments helping benefit life back here on Earth. Here's a quick look at some of the science he enabled during his research-filled stay aboard the world-class laboratory in low Earth orbit.
A lot of science going on today. We got me doing biomole, Doug doing astrobeat. So the scientific team is in California. The payload control center is in Huntsville, and of course I'm here. Pretty cool stuff.
Station Huntsville, Space to Ground 2 for Chris and Cryochiller.
Recording in the name of science. Fecal processing complete. We're working with foam, and this is the FSO. Let's go for it.
And just make sure that the liquid is in the bottom of the tube. You can just do that by giving it a flick of your wrist.
I think all of the things we're working on are applicable not only to life in space, but translate to Earth in some way. We're certainly working on life support systems on the International Space Station that will help keep crews safe as they go beyond low Earth orbit. And that can translate to health systems on Earth as well. It's a really robust science program that we have up here, and I think you'll find a lot of benefits coming back to Earth. busy day of science on board the International Space Station.
Expedition 64 flight engineer Kate Rubins is both a scientist and a NASA astronaut, and there's no better place to be for someone with those two job titles than aboard the International Space Station. The microbiologist says being free from Earth's gravity makes this outpost the perfect place to conduct research.
The reason that you would do any kind of experiment in space is if there's something particular about the space environment, and most often that is microgravity. So mostly the ISS gives us the ability to either do something that we can't do in a facility on Earth or investigate some phenomenon, some property in a way that we can't on Earth. So for example, some of the tissue architecture, these really delicate tissues, as you start to build them up, they would collapse because you have gravity, or the cells would naturally settle to the bottom of the plate. And so you just can't study the answer to the question that you're looking for. So the space station lets us have that ability to either test what the effect of gravity is or remove that problem entirely from our experimental setup. Yeah, the space station's an incredible place to conduct research. It was sort of like being in the world's most amazing lab when I was up there in 2016. So when you're a scientist, you're used to working on one thing over and over and maybe really refining the details on that over the course of a PhD thesis or a lab project. On space station, you get somebody's incredibly refined project times 200 different fields. So for me, it was a chance to learn about all these different areas of science, and they each have a team behind them. So I was usually pretty excited to open the container and do whatever experiment that day brought. I also really got a chance to talk to those PIs, the principal investigators, and those scientific teams, and understand everything that was going on behind their experiments and read their papers. So by the time I got to doing the experiment, I was pretty excited to take it out and to see what was going to change in microgravity. Yeah, science in space, it's an amazing lab and it's incredibly fun. So we are smiling all the time. I'm Kate Rubins. I'm a scientist and an astronaut.
You can't do exploration from inside of a spaceship looking out a window. We really need the astronauts to go out and do exploration.
And so we are trying to provide the best tool to the crew members that we can, no matter where they go. So it's an exploration spacesuit.
This new suit allows the human to move more naturally and more fluidly. The system will adapt to the human inside it, and the human will adapt to the system.
It is like a brand new spacecraft.
Even has the new smell and everything.
It does. New car smell.
It's very exciting. My career happens to coincide with this great opportunity to go back to the moon. Like, I can't believe I'm so lucky just to be here at this time.
The laboratories of the International Space Station provide a home for dozens of experiments at a time in a wide range of scientific disciplines. But the outside of the space station supports science research too. There's a great big experiment out on the starboard truss that was recently put back into service after a series of spacewalks, getting it back to work searching for cosmic particles which originated billions of light years away and which may hold the key to the origin and composition of the universe.
Humans have observed many wonders across the cosmos, yet much of our universe is still shrouded in mystery. Among those mysteries is the formation of our universe, which should have resulted in a balance of matter and its corresponding counterpart, antimatter. Much of that matter is thought to exist in the form of dark matter, which can't be directly observed. Much of the antimatter can't be found at all. Studying fundamental particles originating from sources up to billions of light years away may hold the key to understanding both the composition and history of our universe. Welcome to the world of particle physics, currently being explored from low Earth orbit by the Alpha Magnetic Spectrometer, or AMSO2, installed on the International Space Station, or ISS. Planets, stars, interstellar gas, dust. What we're able to observe across the universe comprises less than 5% of the total content found throughout the universe. The other 95% is dark. Dark matter as well as dark energy. Dark matter doesn't interact with or produce light as far as we know. It doesn't consist of normal matter, or matter that can be observed directly. So how do you improve understanding of something that can't be observed? One way is to look for evidence of its interactions. Kurt Costello, the ISS program chief scientist at Johnson Space Center, explains how the giant magnet of AMSO2 is working to help scientists test and modify their theories. Scientists are using AMSO2 to look at cosmic rays, charged particles that travel near the speed of light. AMSO2 categorizes each cosmic ray, looking at a high energy range to see whether that stellar phenomena that we can measure can account for all of the cosmic rays we're seeing. But if you see something in the spectra that doesn't fit, then this could be evidence of dark matter interactions. By studying cosmic rays, scientists are also able to search for antimatter. The Big Bang theory of the universe's origin requires a 50-50 ratio of matter to antimatter. But to date, the amount of antimatter found doesn't come close to matching the amount of matter known to exist. Costello says one of the goals of the mission is to detect antimatter and see if there are any large collections of it out there somewhere. When particles pass through the strong magnetic field produced by AMSO2, their paths bend. Antimatter particles stand out because their paths bend in the opposite direction compared to matter particles. The instrument searches for antimatter with a sensitivity 3 orders of magnitude greater than the original AMS, which flew in space in June of 1998 aboard the Space Shuttle Discovery. This could support the discovery of antimatter pools that were previously undetectable. A key factor in our ability to get the most out of AMSO2 is time. Originally expected to have a lifespan of 3 years, the instrument has continued to perform into its 8th year of operation aboard the orbiting laboratory. In late 2019 and early 2020, astronauts conducted a series of spacewalks to replace AMSO2's cooling pumps, which were failing. Extending the life of the instrument will provide scientists more time in their quest to unveil some of the universe's greatest mysteries. For more on scientific studies being done on and from the space station, go to www.nasa.gov/ISS-science. For more information about the origins of the universe, visit science.nasa.gov.
We are less than 2 weeks away from marking the 20th anniversary of the start of continuous human presence on the International Space Station, a project that was designed to teach us the things we need to know to explore out beyond low Earth orbit in the years to come. And those years are coming along very soon, as NASA works to return astronauts to the Moon in just a few years. When those future astronauts explore the surface of the Moon, they will be wearing a brand new spacesuit. Here's the story of the Exploration Extravehicular Mobility Unit, the XEMU, the suit that will let astronauts explore like never before.
A new era of exploration is beginning. NASA is building on its experience in low Earth orbit and preparing to go farther, setting up a base camp in orbit around the Moon, known as the Gateway, exploring the surface of the Moon like never before, and preparing to one day go to Mars. To accomplish all this, NASA will need a new spacesuit for its astronauts, one that's more flexible, versatile, and durable than any made before. Engineers are now hard at work designing, building, and testing the new suit, making sure it's up to the task for future exploration. Some of the greatest moments in exploration have taken place with a human in a spacesuit. Whether it was a first journey outside the spacecraft or traversing mountainous moonscapes, the spacesuit made it possible. The act of sending a suited human outside the spacecraft is called EVA.
What is an EVA? EVA is an acronym that stands for Extravehicular Activity, which is what most people know as a spacewalk. It's whenever we take astronauts and we let them go outside to do useful work in the vacuum of space.
The spacesuits currently in use for NASA EVAs were designed in the 1970s for space shuttle missions. They have been upgraded over the years for work on the International Space Station and have served NASA well.
In the past 20 years, there are a handful of types of spacewalks that we've done. We've done planned spacewalks for maintenance. As hardware breaks, we can do contingency spacewalks. As technology improves, we can upgrade hardware. Or like with the Hubble Space Telescope, we're actually repairing very sensitive scientific experiments in order to enable science.
Those EVAs took place in microgravity, where astronauts float and need to use their hands to move from place to place. But moonwalkers, working in 1/6 Earth's gravity, will need spacesuits that let them use their hands and feet, walking to destinations and bending and reaching as they explore. For this new type of work, NASA has been testing prototype planetary suits, culminating in a new suit design, the XEMU.
The XEMU is Exploration Extravehicular Activity Mobility Unit. So it's an exploration spacesuit. So it's a spacesuit that you're going to use as we move forward on Gateway missions and on the lunar missions with Artemis. And then we're using all that to test the suits you would want to use to go to Mars in. So eventually you're going to have to be very independent and very confident in your hardware when you go and do a mission that far away from Earth.
One of the most obvious changes in the new spacesuit is the way astronauts get in and out of it. Donning the current suit is a multi-step process of wriggling into the upper torso and then getting help attaching a pair of space pants. The new generation spacesuit features a hatchback, where astronauts simply slide in and out of the one-piece body of the suit. Another big feature of the suit is the way the astronauts are able to move while wearing it. Apollo astronauts learned they had to hop to get around on the Moon. The suit design sometimes made it difficult for the astronauts to work.
Up. Okay. We see that one went all the way in. Not quite. Like that.
Engineers learned valuable lessons from those Apollo suits. The improved design for the next generation spacesuit will allow astronauts to walk on the Moon, not hop. Additionally, astronauts will experience an improved range of motion.
The new suits, the planetary walking suits we're working on now, we really hope to provide improved mobility and comfort along with reduced injury potential. And really, like I said, provide the best tool to the crew member that we can provide. Then we want to be able to provide them the ability to kneel down and pick up a rock, like they're going to want to do in their geology science that they're working on. We want this to be a very reliable and durable suit so they can use it day after day in a dusty environment and not have to do a lot of maintenance with it while they're needing to do their mission. So there's a lot of those kinds of aspects that go into improving the suit that we're going to provide for the lunar missions.
Improved mobility is not the only feature engineers have been working on. The astronauts will also be carrying a special backpack known as the PLIS.
So the PLIS is the Portable Life Support System. It's the backpack on the spacesuit, and it has all of the interesting parts to keep the crew member alive while they're on their spacewalk. So it has oxygen stored as pressurized gas for breathing, pressure regulators that regulate the oxygen pressure inside the spacesuit, and then a ventilation loop and a water loop that we call the thermal loop that provide trace contaminant and carbon dioxide removal from the breathing environment, and also cooling for the crew member and the suit onboard avionics and electronic systems.
While the PLIS has been on previous spacesuits, this improved version will offer new technology, greater control of its systems for the astronaut, and longer life for each EVA, allowing more exploration.
The PLIS labs are awesome, super fun places, and we physically assemble the parts to build the life support system, and then we test it. It's our opportunity to find things and fix things before we get it on orbit. We love what we do. We really want to see this system fly and be useful and help a person explore the moon in a more capable manner than they were able to do during Apollo. So it's a great job.
So I want you to perform some isolated joint movement to understand how the suit moves and then be out.
Testing for the new spacesuit continues underwater in the Neutral Buoyancy Lab. Here, the weightless environment of space can be simulated to put the suit through its paces.
So being able to test the suit in the pool and microgravity environments allows us to iterate on our design and make it better and get feedback from astronauts and from other instructors and trainers.
Could you reach all the way across and do the cross switches with your opposite arm?
Oh yeah, it's really easy to get all the switches with my opposite arm. I would rate this as excellent.
Come on.
I know, I guess gonna get lower and flatter.
Yeah.
Hold on. Oh my God.
You did it! Very good.
So if this could happen in real life, this is a spectacular translation.
Rex and I are very lucky. It is like a brand new spacecraft.
Even has the new smell and everything.
It does. New car smell.
Spacesuits are also tested in the Active Response Gravity Offload System, or ARGOS.
Yeah, so the Argos electronically is able to tune an astronaut exactly to whatever gravity it is that we're practicing that day, whether that's microgravity, lunar gravity, or Martian gravity. The other nice thing about Argos is you're able to get the instructors and the engineers right next to the astronauts as they're working, helping the astronaut figure out a problem as they work through the development of that test for the suit or for a piece of hardware and get that real-time feedback.
Spacesuit hardware is not the only thing being tested on Earth. NASA is looking at human performance as an important factor in designing EVAs and spacesuits.
So related to a spacesuit, a lot of times people think about the actual engineering, the hardware, the different pieces, but I want to look at the EVA scenario from the human really inside the suit and make sure that their performance, both physically, cognitively, is going well. So we want to look at things like physical exertion, cognitive workload, injury risk, and really just trying to make sure that they're not impaired by the EVA system any more than they have to be.
The NASA team uses virtual reality technology, motion capture, and other tools to study what it takes for a human to conduct an EVA.
And what we're able to do is bring actual, no-kidding data to the table that really removes the opinions. That's probably our primary benefit for how we kind of enhance the EVA community is we take a look at this not from a hardware, not from an operations standpoint first. We look first at the human and then kind of say, what do they need to be able to do to be ready for the job?
All the work on the spacesuit here on Earth is building up to the ultimate test, to fly it in space.
So we're actually building a flight unit of that XEMU, and we're going to launch it to the International Space Station. And we will do an EVA with a current spacesuit, an EMU that we use today, and the XEMU with it. We'll go out in pairs and we'll have the astronauts working together, one in the old suit and one in the new suit, and we'll test its functionality in a microgravity or a low gravity environment out in the vacuum of space. That will help us test a lot of its systems.
The EVA on the space station will set the stage for the future, when the suit will need to perform a variety of missions beyond low Earth orbit.
Yeah, so a great example is NASA's Gateway. So even though it is in lunar orbit, it's still a microgravity platform, so astronauts would still be floating in space. And so we can use a lot of the lessons we learned from the International Space Station to do spacewalks on the Gateway. It's actually really advantageous to use one spacesuit both at Gateway and on the lunar surface. So the exploration spacesuit can do both of those things.
For EVAs on the Moon, the new spacesuit will give astronauts unprecedented abilities as they explore the lunar surface.
Really, this is the first time we're trying to bring a suit that's optimized for human performance and optimized for lunar exploration so that you can actually bend down, interact with the ground, so that you're going to have the visibility that you need, the mobility that you need to accomplish these tasks.
This new suit will allow us the flexibility to really do exploration. Get down on the surface and send geologists to the surface and really let them act like geologists in a spacesuit. This is the first time in history that a suit like that will have been created, and it's really exciting to be part of that. To do what NASA was meant to do, and that is to do exploration. And this suit will really help enable the agency go do exploration.
Well, everyone in my generation wasn't alive the first time we went to the moon, and we want to do it again, and we want to do it better. We want to go do more science, we want to stay longer, we want to get more out of it, and we have the technology to do it now. So we're really excited about it.
With its new technology, new design, greater mobility, and greater versatility in how it can be used, NASA's new spacewalking suit is truly tailored for the next generation of space explorers.
If you want another look at any of these stories we featured today, you can always find them on YouTube and Facebook. And while you're there, feel free to check out the other cool stuff that's available about NASA and America's human spaceflight program. And when you're interested in good conversation about human spaceflight and exploration, the place to go is Houston, We Have a Podcast. It's our weekly show where we talk to folks about their work in all aspects of space exploration. The new episodes go up every Friday, and today, Gary Jordan gets the inside story on the next Crew Dragon mission to the International Space Station in a conversation with lead flight director Anthony Varia. Go to nasa.gov/podcasts for this week's episode and all of our previous episodes. In fact, that's where you'll find the full library of all the NASA podcasts. You can also find them all on Apple Podcasts, Google Podcasts, and SoundCloud.